Okay, so we're going to go back to finding the area under our curve that we were working with in the last video. And it is the V of t equals t squared. And we were working on the interval 0 to 3. And this time we're going to actually find the area under this curve using a left rectangular approximation method. So notice that in my drawing, this rectangle is intersecting the curve at its leftmost point. Same thing with this rectangle and same thing with this rectangle. So the good thing about using a left ram is that you don't have to find the midpoint, which always took an extra step. So here's what I tend to do. I like to list or identify all of the left endpoints. So the first rectangle is formed by going from 0 to 1/4. So that's 0, 1/4, 2/4, and so on. So my first left endpoint is 0. Then my next one is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, 11/4, and that's where we stop, because 12/4 would be at 3. And if we're looking at that rectangle, this rectangle, using the left endpoint, would be at this endpoint here, or the leftmost endpoint of this rectangle. So you can't use 12/4 for left endpoints. So we know we need to find all of the heights. So we need to find the heights of all the rectangles. So we do that by finding or evaluating the function, the velocity function, at each of these endpoints. So V of 0 will be 0 squared. V of 1/4 will be 1/4 squared, which is 1/16. V of 2/4 will be 4/16. V of 3/4, and hopefully we're going to pick up on the pattern here in just a minute, 9/16, and so on. So the height of the first rectangle is 0. The second one is 1/16, the third one 4/16, 9/16, and so on. So if I want to find the area, then I think I have enough information for me to pick up on the pattern for all of the heights, and all of the widths are going to be the same. So remembering that area is length times width, or base times height, then our area can be found by taking the 1/4, which is that common width, and then multiplying it by the sum of all the heights. So V of 0 was 0, plus 1/16, plus 4/16, plus 9/16, plus, and then all of the ones until we get down to 100 over 16 plus the 11 squared is 121 over 16. So we're going to multiply, or we're going to find the sum of all the heights, and then we can just multiply it by 1/4. So the area, when I calculate this, I get 1/4 times 506 over 16, which actually turns out to be 506 rather, over 64, which is approximately 7.906. So using the left endpoint, or the left ram, the left rectangular approximation, the area under the curve is approximately 7.906 units. So compare that to the MRAM. Now, in our last session, we found that the MRAM gave us an area of 8.984. And I'll scoot that up a little bit. So 8.894 was the midpoint, 7.906 is the left RAM. So if you look at what we're working with, the midpoint used rectangles that were partly outside of the graph. So it makes sense that the midpoint approximation method is going to be a number that is higher. Okay, so now let's go about finding the area under this same curve with these same rectangles, but using a right RAM, the right rectangular approximation method. So again, here's what the graph looks like. And when I draw the rectangles, I end up with something that looks like this. And y'all know my drawings are terrible. So if you look, each rectangle, the intersection of the rectangle and the curve is now using the rightmost point on the rectangle. So that's where we're using the right RAM. So our endpoints, being that this goes from 0 to 3, our right endpoints, are going to start not with 0, but we're going to start with the 1/4. So 1/4, 2/4, 3/4, 4/4, and then this is just going to continue until we actually get to 12/4, because this last rectangle will intersect this curve at the rightmost endpoint. So when we're in this particular scenario, our right endpoints don't start at 0, we start with 1/4, but we end at 12/4, and with the left RAM, we start with the endpoint of 0 and we end at 11 squared over 16. So you kind of have to pay attention to those things. So I don't know if you're paying attention, but when we go to find, do I really need to find all of the heights? Okay, we'll do so. Let's just start with finding the heights. We will have V of 1/4 plus V of 2/4 plus all the way down to 12/4. So we'll evaluate V of 12/4. Those will be all of our heights. Well, we already have our heights from, we have all of our heights from our left RAM. So this time we just don't start with 0, and we'll add 144 over 16. All right, so I'm going to scoot that up. Area equals, all of the rectangles still have a base or a width of 1/4. My first height is going to be 1/16, because I already did the work for the last problem, plus 4/16 plus 9/16 plus, and this time we will go down to 144 over 16. And so when we clean this up, we get 1/4 times, this is 650 over 16, which is going to be approximately 650 over 64, which is then going to give us 10.156. So we've just found the area under the curve of our original graph using 3 approximation methods. Our left RAM, let's get that up some. The left RAM was less than the MRAM, which was less than the right RAM. And so the left RAM, we had a value of 7.906. Our MRAM was 8.984, and our right RAM is 10.156. So thinking in terms of what method we used, the values should make sense, that the midpoint should be between the left RAM and the right RAM. And because the right RAM produced rectangles that were outside of the curve instead of underneath it, or as well as underneath it, the 10.56 is going to be an overestimate, and the left RAM will be an underestimate. And the midpoint RAM is probably going to be the one that's going to give us the most accurate value for the area. So that's the basis for finding the area under a curve. And so what these values mean is determined by the context of the problem. This, remember, the graph of this was a velocity function. And so the area under the curve is going to be information regarding total change in position or distance, something along those lines. So the context of the problem is going to indicate what those values represent. So in the next part of this lesson, we will take a look at finding area under a curve when you're given a table of values instead of a function. So until next time.